Hello everyone, I'm Clark. I will elaborate on how I use the knowledge I gained from Antarctica to make a design in my career point, Hobart. These pages are a brief review of the first half semester and what I have gained from Lake Vostok research. I have put three key words in my toolbox: circulation, erosion, and accumulation. These three processes all contribute to the dynamic balance in Lake Vostok. At the same time, section sinking and the method of adapting transect are the acquisitions as well. Now let's see how I use them in my quarry point. Here is the basic geographic information of my quarry point and its surroundings. During the research, I noticed flood from Mount Wellington and the pollution from Derwent River are the main challenges and threats in my quarry point. They helped me establish the first and the second half of my transect respectively. Like what I have done in Lake Vostok, I overlapped the relative maps together to find valuable information and further implication. After this process, it is clear the longest trajectory of the flood is from the top of Mount Wellington. The rain flows along the valley, then reaches the side. I continue to track the flood, and it will join the ocean at Stone Bay. Then someday it will become rain again in Hobart. At the same time, the salmon aquaculture leases are in this location. The terms of excrement and the excess nutrition are widely believed as a threat to the local environment, including Derwent River. So I chose here as the endpoint. The transect has been settled. It starts around Mount Wellington, crosses Macquarie Point, then ends in Stone Bay. The basis for this establishment is from the keywords in my toolbox. This is the master plan from Mona, and here is the design boundary and the explicit trajectory on the side. I established two frames in this side based on the two challenges I mentioned before. Frame 1 covers the flood area in Macquarie Point, and the second one mainly focuses on the pollution in Derwent River. I found the sewer system could sometimes overflow when heavy rain or storm comes. The stormwater flows into the river along with a variety of pollutants, including litter, particularly floating plastics, soil, and fertilizers without treatment. At the same time, excess nutrients that come from salmon hatcheries and salmon farms and wastewater treatment plants can trigger algal blooms that threaten fish habitat and deplete oxygen. In addition, the zinc pollution from the near-star smelter is a crucial threat to the ecosystem. Now, if we put all the elements in one drawing, it is clear that the design of the coastline is key to dealing with these aspects. I will propose my design addressing pollution from flood and pollution from the river at the waterfront edge in Macquarie Point. When talking about pollution in water, it is natural to think of purification or filtration. So how does nature purify or filter? I listed the precedents I found here. Though the three images come from various organs, they have a similar morphological feature, increasing the contact surface by folds, making the filtering system as efficient as possible. So how about using this method in the Macquarie Point's coastline? This is the answer I got to the question, and I will explain how this system works. When flood from the streets arrives here, the landscape hills will guide it into the particular trajectory in my system. The plastics and the other litter in the flood will be caught by the bending construct before they could reach Derwent River. At the same time, the group of ponds in the system will raise aquatic plants, which can help sequestrate the nitrogen and the phosphorus in the river, attempting to deal with the eutrophication. When we are back to land, several water sample capsules will be on the hills. They are here presenting the zinc concentration from decades to decades, using reagent to make the color noticeable to the public. The effort and the process of reducing heavy metal in this river can be visualized to the public, hoping one day one of the water capsules will be transparent. To think further, this comprehensive system could be built along the Derwent River. Then the whole river could function as a filter system, reducing the human activity's impact on the ecosystem. In conclusion, I used the new kind of section sinking I got from Antarctica and the various types of processes from my toolbox to counteract the ecosystem threat in an urban public space. Since my topic is Lake Vostok in the first half semester, I didn't make a specific connection between the lake and the Macquarie Point. However, I used the methodology in interpreting the movement of particular substances as the driving force of my design. Thank you.